Okay, we're going to look at two geometry reasons that use the angles in a quadrilateral. The first one is that the opposite angles in a quadrilateral sum to 180 degrees. So if you have a quadrilateral that fits in a circle, so the points sit on the circumference on the outside of a circle, you know that the two opposite angles always add up to 180 degrees. Now, there's a proof for this, and we use an angle at the center is 2 times the angle at the circumference. Go through this proof really carefully. You're trying to prove that angle D plus angle B equals 180 degrees, that those opposite angles really do to add to equal 180. And when you look through this thing, there's always, you start off with things that are given, that you've got a quadrilateral that's cyclic with a center 0. And then you almost always do some kind of construction. And here we draw OA and OC. We put in these two radiuses here, the two radii. And then there's a proof. And go through the points really carefully yourself and make sure you can do it. You might get this proof on an exam that's worth 5 or 6 marks, so it's good to do. There's another important quadrilateral rule. One is that the opposite angles add up to 180, but the other one is if a quadrilateral is cyclic, then the exterior angle, you see if you extend one of the lines, this is called an exterior angle, it's equal to the interior opposite angle, the angle opposite that angle on the other side, and on the inside, the interior opposite angle. When you write the reason, just write this down, exterior angle of cyclic quad. That's all you have to write. So let's see how we would use this in a question. Here's an example from some textbook anyways, and I'm going to show it to you right now. Different parts. Say you have this circle with all these letters you were supposed to figure out. And you're given that A, B, C, D is a cyclic quadrilateral, and that B, C, D, E is a cyclic. So you've got 2 cyclic quadrilaterals. Well, let's just go through it. This one's got to be 80 degrees because these add up to 180. So you can write A as 80 and write opposite angles of a cyclic quad, just like that. Okay, B must equal 70 degrees because there's a cyclic quad BCDE, and there's the exterior angle. It's got to be the same as this opposite interior angle, which is 70 degrees. C is 80 degrees. Okay, let's see if we can figure out why C is 80 degrees. Well, there's opposite angles in the cyclic quad BCDE. Those opposite angles get added to 180. And then D is 30 degrees. Well, you see, this is 30 degrees. It opens up to the chord AE. There's not a chord there, but that's a segment of the circle. And D opens up to the same segment AE of the circle. So angles in the same segment mean that those angles have to be the same. So D is 30. And then E is 70 degrees. E is 70 degrees. Well, if we know C and we know D, we go 180 minus those two added together, we'll get that 70 degrees. Okay, we've got 6 questions that deal with the opposite interior angles and a few other geometry reasons, and 6 questions that deal with exterior angles and opposite angles too. And we've got memos to go with it, so hopefully you'll be able to do them.